Let's talk quickly about the fitted values. So remember, in this case, our regression that we wanted, our least squares equation that we wanted to minimize was y minus beta naught jn minus beta 1 x squared, and that resulted in a fitted line. Let's say just now a conceptual y equals beta naught plus beta 1 times a conceptual x. That's the fitted line is that quantity. Okay? And so how do we predict an x at, or how do we predict a y at a new x value? Well, the easiest way to do that is simply to plug in the new x value there, and you get the y predicted. Let's call it y hat predicted at that specific x value. Now, some particular values of y that we want to predict at, or the most obvious ones that we would want to predict at, are where we actually observe the x's. Okay, so this is the process. Here's our fitted data. Here's our data. Okay. Here's our fitted line. Okay. And then these values, right? These values projected on the lines are called the y hat values. So to get our y hat values, of course, to get the vector of y hat values, we would just need to take beta naught hat times jn plus beta 1 hat times x, right? Remember, jn is an m by 1 vector, x is an m by 1 vector, beta naught and beta 1 are just scalars. That gives us our y hat values. So you can think in a lot of ways our least squares criteria is really minimizing some of the squared deviations around the fitted values.